The B61-12 nuclear bomb represents one of the most significant advancements in U.S. tactical nuclear weapons in decades. Its development reflects decades of technological refinement, combining lessons learned from previous generations of the B61 series with modern engineering, precision guidance, and modular design principles. Unlike earlier versions, which relied primarily on gravity and rudimentary targeting, the B61-12 incorporates a tail kit assembly that functions as a highly precise guidance system. This tail kit allows the bomb to adjust its trajectory during free fall, correcting for environmental conditions such as wind, air density, and minor deviations from the release point. The precision offered by the tail kit is measured in meters, meaning that even at high altitudes or long ranges, the weapon can reliably reach its intended target while minimizing unintended collateral damage. This precision is a crucial feature in maintaining strategic deterrence credibility while also meeting modern safety and operational standards. The integration of the B61-12 with the F-35 fighter jet represents a technological and strategic evolution in the way the United States deploys its nuclear arsenal. The F-35 is designed from the ground up to operate in high-threat environments where stealth, situational awareness, and advanced avionics are critical. By pairing the F-35 with the B61-12, the U.S. creates a nuclear-capable delivery platform that combines the bomb's precision with the aircraft's low observable characteristics and sophisticated sensor networks. During flight tests, inert versions of the B61-12 are carried by the F-35 to replicate the exact weight, aerodynamic characteristics, and release profile of the live weapon. These tests allow engineers and pilots to validate every aspect of the bomb-aircraft interface without the risks associated with handling live nuclear material. The flight tests are highly controlled operations that examine multiple technical dimensions. One of the primary considerations is aerodynamics during release. When a bomb is released from an aircraft at high speed, particularly from supersonic flight or high-altitude drops, it is subjected to complex air currents, pressure gradients, and gravitational forces. The tail kit assembly of the B61-12 must stabilize the bomb, deploy fins at precise moments, and adjust its trajectory dynamically to ensure the path remains accurate. Engineers measure these effects meticulously using onboard sensors and telemetry systems in the test units. The tests also evaluate the bomb's ability to maintain stability under extreme maneuvers, including sharp banking, sudden altitude changes, or evasive aircraft actions, which are scenarios that could occur in operational deployment. Another critical component evaluated during these tests is the integration of the B61-12 guidance system with the F-35 avionics. The F-35 provides the pilot with a digital interface for weapon selection, release timing, trajectory calculations, and target information. This interface allows the pilot to program the bomb for specific delivery modes, adjust for environmental conditions, and receive real-time feedback on expected impact points. The interaction between the aircraft and bomb is complex. The release must account for aircraft speed, altitude, heading, wind conditions, and target coordinates, all while ensuring that the bomb's internal guidance system can make fine corrections to hit the target precisely. This integration is essential to ensure that, in an operational scenario, pilots can rely on the system without needing to perform manual calculations under stress. The B61-12 flight tests also serve a broader strategic function beyond technical validation. The United States maintains its nuclear deterrent through a carefully balanced triad, consisting of land-based intercontinental ballistic missiles, submarine-launched ballistic missiles, and strategic bombers capable of carrying nuclear weapons. The B61-12, when paired with fighter aircraft like the F-35, enhances the tactical component of this triad by providing flexible, precise options for deterrence. Tactical nuclear weapons are intended to give the United States the ability to respond credibly to emerging threats while minimizing the scale of destruction compared to strategic strikes. By demonstrating that the F-35 can reliably deliver the B61-12 under realistic flight conditions, the U.S. signals that its nuclear forces are modern, adaptable, and operationally credible. This credibility is central to deterrence strategy, as adversaries must assume that any attempt to challenge U.S. interests could be met with precise, effective, and timely nuclear response options. Flight tests also play a crucial role in stockpile stewardship. Nuclear weapons contain components that age over time, including high explosives, guidance electronics, and safety mechanisms. Regular flight tests with inert versions of the bombs allow engineers to monitor performance, detect potential wear or degradation, and verify that all systems continue to function as designed. This reduces the need for live detonations, which are environmentally and politically sensitive, while ensuring that the nuclear stockpile remains safe, secure, and reliable. Data collected during these tests informs maintenance schedules, engineering upgrades, and long-term modernization programs, which collectively extend the service life of U.S. nuclear assets for decades. From an operational perspective, these tests evaluate multiple flight scenarios, including low-altitude and high-altitude releases, supersonic and subsonic approaches, and varying degrees of evasive maneuvering. Low-altitude releases are designed to reduce the time an aircraft is exposed to enemy radar, while high-altitude releases maximize range and allow for greater flexibility in strike planning. Supersonic approaches reduce exposure time but increase aerodynamic stress on the bomb, requiring precise stabilization from the tail kit. Pilots and engineers also simulate combat conditions, including adverse weather, turbulence, and limited visibility, to ensure that the integrated system performs reliably under all conditions. The combination of the F-35 and B61-12 is also a significant leap in terms of survivability and operational flexibility. The F-35's stealth features allow it to penetrate contested airspace with a reduced likelihood of detection, which is crucial in maintaining the credibility of a tactical nuclear strike option. Its advanced sensors allow pilots to navigate complex threat environments, detect potential interception attempts, and adjust mission parameters in real time. When coupled with the precision of the B61-12, this capability ensures that nuclear strikes can be delivered effectively without unnecessary escalation or collateral damage, reinforcing the strategic message that the United States possesses modern, controlled, and responsible nuclear options. Beyond the technical and operational factors, these flight tests contribute to broader deterrence messaging. They demonstrate to allies and potential adversaries alike that the United States maintains a nuclear force that is not only technologically advanced but also operationally ready. By validating the integration of the B61-12 with the F-35, the U.S. shows that it can deploy nuclear weapons with precision, speed, and reliability. This modernized capability reduces uncertainty for allies who rely on U.S. deterrence and communicates to potential adversaries that any aggressive action would be met with a credible, precise, and adaptive nuclear response. In addition, the B61-12 modernization program reflects a broader commitment to combining safety, reliability, and precision. The internal components include safety mechanisms that prevent accidental detonation, enhanced guidance systems that correct flight paths dynamically, and modular designs that allow for easier maintenance and upgrades over time. Each flight test not only validates these systems but also provides critical data for future improvements. Over time, this continuous testing and refinement process ensures that the weapon system remains capable of meeting emerging threats, adapting to new operational environments, and integrating with future aircraft and delivery systems. The ongoing flight tests of the B61-12 with F-35 aircraft illustrate a highly sophisticated interplay between advanced nuclear weapons design, next-generation aircraft capabilities, and strategic deterrence planning. They demonstrate that the United States possesses a nuclear posture that is resilient, modern, and adaptable. These tests are far more than technical exercises. They ensure the operational readiness of a key component of U.S. defense, maintain the safety and reliability of the nuclear stockpile, and reinforce the credibility of the American deterrent in a complex global security environment. Each successful test confirms that the United States remains at the forefront of nuclear modernization, capable of deploying precision, reliable, and flexible nuclear forces to address evolving strategic challenges for decades to come.